vagaries of my mouse and the arrow drawing here notwithstanding. So what we end up having is, if you were to trace the path of an air parcel, say an air parcel right here, right, where has it been? Well, it's been over this short stretch of the Gulf of Mexico. It's been picking up some heat and moisture there, but it hasn't been there for very long because the winds in this part of the storm are somewhat strong now. But then before that, it's been over the Yucatan. It's been over central southern Mexico here. It's been over eastern Mexico. Right, you can imagine these air parcels that are making this big spiraling loop into the center of the storm, and they're spending a whole lot of time over land. And that's why we have this dry slot, because while these air parcels, you can imagine just little chunks of air moving through, while they're moving over land, they can't pick up any heat or moisture because there's really not a whole lot of that, especially in the sort of arid terrain of Mexico. Um, so you get pretty dry air. Anyways, that's what we're seeing wrapping into the storm here. But within that, we have this new burst of convective activity. And this is occurring right near the center of the storm, which is located right here. And this new burst of convection is pretty much encircled the center. There's a gap out here to the northeast. So we'll be watching to see if that fills in, to what extent that fills in. But this is what's going to be the core of the hurricane. This is where the worst weather is going to be. It's where the most intense thunderstorm activity, the most intense wind, the most intense rain. That's where you're going to find it here. And we'll see to what extent this can close off, right? Because if we can get this to build a full ring around the center here, then we could really have this, do a quick burst of intensification. Will it be rapid intensification? I don't really know if it'll get to that threshold or not, but it's possible. The threshold being an increase of 30 knots in 24 hours. So that's a lot. But it's possible if we can close this off. But if it remains open, then it's going to still be ingesting some of this dry air into the center of the storm. And that's going to make it hard for the storm to really get going in a dramatic sense. So while we might, pop back up to say 75 miles an hour, currently at 65 miles an hour right now as of the advisory at 8 o'clock. So we'll almost certainly get back to hurricane strength here in the next 24 hours as the storm moves off to the north and eventually northwest or northeast. But we're going to need to close off this this dry slot here before we're going to see much more than that. So this is the corridor of heavy weather. It's going to go something like this into southeastern Louisiana and then up through southern Mississippi into Alabama. This is a very rough approximation. Please don't take this too literally. But anyways, this is basically what you're looking at for the corridor of strongest winds and heaviest rain right along that path there. But it's important to remember that dangerous weather extends even outside this, wherever this core goes, right? And of course, we could argue all day long, and there are people trying to figure out whether the western boundary of this core is going to go, is it over here? Is it over here? Right? That makes a huge difference if you're right along the periphery, where exactly the storm center tracks. Will make a huge difference for impacts in New Orleans, in places just west of New Orleans, as well as off to the east, right? You can imagine being here along the Alabama-Florida border. If this thing ticks east a little bit, you could be right in the middle of this core. If it ticks west a little bit, you're going to be really on the outer edge. So the core track is important for folks right along the periphery of this sort of corridor that I've highlighted. It's not really important for folks right down the middle who are going to get the heavy weather no matter what. So Gulfport, Mississippi, Biloxi, Mississippi, you're pretty much locked in for hurricane force winds, torrential rain, storm surge of 4 to 6 plus feet, locally higher down here along the coastline. The ticks east or west at this point are really only on the order of 5 to 10 to 15 miles, maybe 25 miles. So that really is not much of a worry or a topic of discussion for this portion of southeastern Louisiana and southern Mississippi. It's really the Alabama coast, the far western Florida panhandle, and then portions of Louisiana a little bit farther west that are concerned about the wobbles that the storm might take in the next 24 hours. So outside of the core, we have this big outer band, and it extends sort of parallel to that dry slot, something like this. This thing is huge, right? It spans nearly the entire width of the Gulf of Mexico. Earlier today, the convective activity associated with this outer band was really intense, and that's part of what contributed to the center lacking convection, right? Because when you have air rising out over the outermost parts of the storm, let's see if I can find a good color to highlight this. All right, so when you have air rising in the outer edges of the storm, you can imagine all these thunderstorm updrafts going like this. Well, it reaches the top of the atmosphere and it cannot rise anymore, so it will move outward, and it moves outward. And what you end up getting is a whole bunch of air piling up, not only away from the storm center, but also over the storm center, right? Some of this air is moving towards the storm. And when you have this pile up, the atmospheric pile up here at the top of the atmosphere, this forces descending motion, where you see this convergence in the upper levels. So it's just the sort of what goes up must come down, and that going down happens both way outside the storm, right? That's why we saw temperatures in the upper 90s over parts of the Florida Peninsula today. That descending motion contributing to extreme heat, clear skies. That descending motion was also occurring over the storm center, and that was inhibiting the development of new thunderstorms. So now that the outer band has become less convectively active, that's why we're starting to see thunderstorm activity pick up back up near the center. But regardless of that, you still have these bands of showers and thunderstorms that are extremely far from the center, right? We're talking 200 plus miles here, and in these bands, you're going to see gusty winds, you're going to see heavy rain, and you're going to see the possibility of tornadoes. So as the storm center moves something like this, right, up into southeastern Louisiana, southern Mississippi, into Alabama, you're going to get these outer bands that are going to be dragged, up into the Florida Panhandle, into southeastern Alabama, into southwestern Georgia. And if you're in these areas, first of all, you're already seeing one of these outer bands, right? It's right here, that thunderstorm activity. You need to be ready for the possibility of tornadoes. That's a big risk in these outer bands. So even if you're not currently expecting hurricane force winds from the storm circulation center itself, you definitely need to be aware of the weather around you, because tornadoes could be causing problems relatively far from the center. Um, Another thing to note is that as the storm moves onshore, so when it's somewhere around here, and we're thinking this is going to be about this time tomorrow night, so we got about 24 hours before landfall, give or take a little bit. The winds, remember, are spinning counterclockwise, so we have winds that are coming in off the Gulf of Mexico, and that's going to be true not just right where the storm is moving onshore, but also relatively far from the storm center. So the Big Bend of Florida, the northern coast of Florida here along the Panhandle, this area all the way into Mississippi, and then of course the area right near the storm center. But you got to worry about storm surge here, even 50, 100, 150 miles east of the storm center track. You're going to get this onshore flow that's going to push the water in from the Gulf of Mexico into the bays and inlets here, and that's going to cause storm surge problems. So it's not going to be nearly as big as, say, Bay St. Louis or Gulfport, Mississippi. But 2 to 4 feet of storm surge expected over here, even as far down as the Big Bend region, 1 to 3 feet of storm surge. That's going to cause some localized issues. So you should be aware of low-lying roads might be covered in water. You do not want to drive through those under any circumstances. So keep that in mind if you're down around that area. All right, well, that's enough of talking about this satellite image. Of course, we could keep going on and on. I mean, the one egregious, omission I made here is the upper level anticyclone. You can see these cirrus clouds spilling away from the storm, and that's an indication that we have good venting of the system. That helps to make sure the descent is focused away from the storm rather than over the storm. All right, so enough of this satellite image. You're probably tired of looking at that at this point. This is what the core looks like. You can see they just switched the mesoscale sectors. So we're still dealing with that dry slot. We already talked about that, but this is pretty intense convection now, getting the cloud tops into the minus 75 to minus 80 degrees Celsius range. That's pretty impressive. We'll watch to see if these thunderstorms can wrap all the way around the center at some point later today. So how does the environment look for Zeta as it moves closer to the Louisiana coastline? Well, this is a look at the upper levels, and it's a little bit complicated to describe exactly what this is showing you physically. But the blue area is basically warm air aloft, and the warm air aloft, that is generating this anticyclonic flow. So you can see if you look at the wind barbs, the winds are going like this. They're going in a clockwise direction. That's indicative of high pressure. That's good for the hurricane, which wants to vent the warm air that it's producing in the thunderstorms. It's racing upwards through the atmosphere. It wants to vent all that warm air out away from the center so it can go sink somewhere else and not interrupt the thunderstorm updrafts. So there's going to be plenty of that. The ventilation is going to be assisted by this upper level trough over Texas. That is going to be sort of sucking this air off to the north. And then there's also this big upper level trough over the Central Caribbean. That's going to be sucking the air off to the south and east. So we have an upper level environment that's really favorable for intensification by tomorrow morning. The drawback for intensification is the lack of oceanic heat content. So I did not have this pulled up automatically, but it won't be hard to go find. Yeah, here we go. All right. Maybe not the best zoom here, but you get the idea. So if we look over here, this is the ocean heat content. This is how much fuel a cyclone has available. You can see that while Zeta was over the Caribbean, it had rocket fuel. I mean, this is the warmest water you can find pretty much anywhere on Earth right now. So deep water, deep warm water, plenty of it available. But now as you move into the Gulf of Mexico, right, this is where the storm is now. It has until it gets to about 25 north, right, which is right there. It has decent but not explosive fuel, and then past that it gets pretty chilly, and especially as you move into the shelf, which we can see by going back over to the Tropical Tidbits site. They have some great ocean products here. If you get to the shelf waters, you're really cutting down on the amount of energy that you have. So 26 degrees Celsius is the cutoff, normally cited for what's supportive of a tropical cyclone. And you can see that 26 Celsius line is lurking south of Louisiana. So there'll be a time in the last, say, 2 to 3 hours before landfall where the ocean water will not even be supportive of a tropical storm. But you got to remember that hurricanes don't just poof instantly, right? There's a lot of momentum. These things have been, this thing has been spinning since Sunday, right? It's generated all this angular momentum, and it's been spinning and spinning and spinning, and it's not just going to go poof as soon as it crosses 26 Celsius. That's not the magic number that's going to be the death of the hurricane. So inertia is really going to be working against us here in parts of southeastern Louisiana. So this is why we're thinking that the storm will probably continue to intensify as it moves through here. Once it hits around 25 degrees north, which is expected tomorrow morning, then it'll start to, this is probably where it reaches its peak intensity. So we have about 12 hours before peak intensity, maybe 15 or 18 hours, depending on how everything works out. And then in the final few hours before landfall, tomorrow afternoon into the evening, we'll likely start to see a few miles an hour, say, shaved off the maximum winds. Doesn't mean it's any less dangerous of a cyclone, because I promise you won't be able to tell the difference between 100 miles an hour and 95 miles an hour. Both are going to cause major problems for the areas right along and just east of the storm track. That's where you're going to see your highest winds. But then also remember that the water is coming in no matter what the maximum intensity is. The amount of storm surge you get is pretty much set by the size of the storm, which is, as we saw earlier, this is a big storm. So the storm surge is being generated over a wide area, and it's generated before the storm makes landfall. So the surge is baked in. No matter what you see happen to the intensity in the last few hours, that does not change the storm surge impacts at all. So as far as the rainfall from the system goes, it's really not a big issue. The maximum rainfall expected is like 5 inches. This can be moving so fast, it's not going to have time to drop that much water. But of course, 5 inches of rain in 6 hours, that'll cause some flash flooding in the normal low-lying spots. Okay, so what are we thinking? Maybe a little bit of a deeper dive into the dynamics of the storm as it's coming on shore. This is the H-Wharf model. It, as they say, runs a little hot, so don't take the verbatim, 962 millibars. That would be really on the upper edge of what I would consider physically plausible at this point. But we can't totally dismiss that possibility. But either way, there's some good tools that we can use here to evaluate the system's forecast. So as far as the environment goes, let's plot the best way of looking at a cyclone's environment is to take this area average sounding that subtracts out all the vortex and just gives you what's happening around the storm. And so you can see here by tomorrow morning, we have still a pretty favorable environment. So what are the things we're looking for? We want to make sure that the dew point line is relatively close to the temperature line. So the fact that we're pretty close throughout the entire sounding here means that we have relatively moist air throughout the atmosphere. That's important because dry air will cause cooling and it'll make there be downdrafts where there should be updrafts, and that's not good for the hurricane. We're also looking for the amount of CAPE, so the instability, and that's the area between this purple dashed line and the red line. And you can see that we have some area between them. It's not record breaking, but it'll get the job done. And then also what we're interested in is the wind profile. So you can see here in the low levels of the atmosphere, we have these southeasterly winds. They're about 10 to 15 knots. In the mid levels of the atmosphere, we have about 15 knot southerly winds. And in the sort of mid to upper levels, we have this area of 20 knot southwesterly winds. So we don't have that much change of a wind speed with height, but we do have a substantial change in wind direction with height. That's what we call wind shear. So we have 17 knots of wind shear as computed by the algorithm that runs these things. So that's, I would say, moderate. That'll let a storm intensify, but probably not supportive of really rapid intensification. But you never know. We've seen sheared intensification happen before. 17 knots won't rip a storm apart, though. But by the time the storm gets closer to the coast, so say plot the same thing, I guess 18Z is the closest pre-landfall point we have. We'll plot the same thing and see that shear has increased substantially. So now, instead of having 17 knots, we have 32 knots. And that's because these upper level southwesterlies are really kicking into gear. We're still seeing the southeasterly flow in the low levels. So the wind direction is changing with height. And that's going to be put some stress on the cyclone's vortex. We can see that here with the storm-centered cross sections. So what shear does is it tilts the vortex. The hurricane should be standing straight up pretty much. But you can see here that the vortex is tilted off to the north and east. And that is a sign that the system is being disrupted by wind shear. So that's what we're going to watch. We're also going to be watching the import of dry air. So you can see here, this is a wedge of dry air that's being driven into the storm from the west by that westerly wind flow that we've seen aloft. And basically, if that dry air can make it into the storm's core, the eye wall, it will result in cooling because there'll be evaporation that happens here. The evaporation will suck heat energy out of the air, and the result will be descending motion, and that will shut down the updrafts. That'll kill the storm right off. But again, none of these processes are instantaneous, so we have to wait for them to really disrupt the storm enough to bring down the winds and the rain and stuff, and that's not going to happen until the system is well inland. So take the storm seriously. If you are in parts of Louisiana here, this is going to be a relatively compact inner core moving quickly inland. And because it's moving so fast, the winds are going to continue to be relatively strong pretty far inland. So you can see here, this is the forecast for maybe 50-mile-an-hour winds all the way up into northern Alabama and northwestern Georgia. So that's power outage concern here, even after the storm loses its title of being hurricane. So that pretty much covers the tropical aspects of the system. I'll leave you here with one last entertaining look at how the storm is expected to evolve. This is from the NAM model. Hopefully I can get the right one of these versions up here. This is the NAM model showing you how the storm is expected to transition into an extratropical cyclone as it moves north. So there's Zeta, you can see moving inland over southeastern Louisiana. And then it's going to get sort of caught up with this larger cold front. Cold front extends something like this. And you can see that the Zeta will sort of merge with this cold front, but it'll send all this moisture northward. And you can see this broad area of rain that's being supported in part by the moisture from Zeta. And then as cold air pours in from Canada, the northern edge of that precipitation shield will turn over to snow in parts of the Northeast on Friday. So not every day that you get a hurricane remnants producing heavy snow. So I figured I'd give that a mention before I headed out. But with that, have a great evening.
To support this project while gaining access to all of our innovative, award-winning...
If you are in the path of the storm, and I'll have another update at some point tomorrow. Thanks so much for listening.